In this presentation, I'm going to discuss and present the capabilities are embedded in Eushaw Dynamics Simulator. And we think that this simulator can be the solution for digitalization and acts as a solution for the next era. First of all, I have to explain why we need such application. Currently, none of the companies have such application, but why we need such application. Uh, we gather enormous amount of data every day, and which we not used to have such amount of data in our companies. And the problem with such amount of data is that we have to create and have the dashboard application that has the capability of storing these material in more framework, structure framework that be user friendly to analyze and also be using those. And also we need to be creating more automations and optimization techniques. And so the software or the application have to be capable of implementing more optimized methods. And also we had less experienced people day to day in this environment. As a result of oil price, we lost all the senior staff and we left with all these new hirings. So the companies, instead of hiring the more senior staff, can acquire the software or application that think in the more smart way and kind of utilize the people that we have that can be from the day one be capable of running a simulation, using the data, and kind of act as a senior staff and make good judgments about the future operations. So now we understand why. We should see what would be the right solution for doing such application and moving to digitalization. So the the requirement for such digitalization is to have an application or a software that be very user friendly and also take care of automation optimization. And the main part of that optimization would be conducting the history match fully automated without any requirement to human being judgments, and also to run it in very short time, like a few minutes, instead of taking a team's time and running different scenario for days and days and waiting for the software to give a result and see at the end that you reach the history match. We should have the application that run everything in a few minutes. What would be the problem if we not modeling things right and we don't do history matching wrong and we don't have that much time? So for example, like in these example, we try to show the new completions that we're using in these thermal operations and also conventional operation, which is flow control device. And from this point on, I'm using FCD instead of flow control device. But using FCD, we create a very nonlinear system in the well bore. And the problem is, after drilling, we don't have much time to decide what sort of a completion we're going to go, what the restriction is, how is the format is. So we don't have much time. So we have to make judgments, and normally those judgments are all based on experience rather than modeling because you don't have time. So that's what would happen in this case. For example, we have two cases here, and in one case, we put the FCDs, and after putting FCDs, we see the positive uplift. But in just one well or two well distance from the well, in pretty much the same geology, but different historical operation on the well, we put the FCD and we see totally negative impact. less than 50% as what we have in this well. So instead of gaining, and we put these expensive tools inside the reservoir, and we see negative impact. So how do you should think and run the history match? Well, so what is the example? This is one example of how the Eushaw software creates this amazing type of automated history match. So it's not just history match. So we did it shortly on one zone of history matching, very short time, but you can see the predictability of this software. And even after 4 years, the simulation is very close to what the data points are. And also in this one, had used a different type of physics, like erosion effects on the reservoir, which there's no software in the world that can capture that, to see what would be the effect on the history matching, and to see the effects is pretty nicely captured. So other than erosion, there are other physics that are not captured in most of these simulation softwares that are also considered in this. So it says automated history match, but you also have other capabilities capturing new physics in the software that none of the other software are capable of. And one of the important ones is steam coning and gas coning. For example, in thermal operation, we do have a steam coning in once you run at the very low temperature, high temperatures, the producer, and you suck at the very high low pressures, then the result would be a steam flash and a steam coning at the edge of the well bore. And you see here the steam quality created and start flashing and start breakthrough. And as a result, the mobility of the liquid phase goes close to zero, and reduction of the production happening. There is no software in the world that captures such a phenomena, and this is the only software in the world can capture it. And that's really important in the cases that we want to see the effects of these new compilations, because the new variable effect is more important in designing our production and completion than what happens like 50 meter away or 60 meter away by discretizing the whole reservoir. Most of the production engineers require to know what's the corrosion status is on the wells, and how much of wells are corroded. The problem is most of these production engineers have very small knowledge on the corrosion, and that's not expertise. Their expertise is on the different aspects, and also the knowledge about the amount of material they have to put in these corrosion softwares, get it from the reservoir models to convert it to in the format that the corrosion software is needed is also very limited. So in this software, we create a platform that also that is, as you running the reservoir simulation, you also run and model your corrosion. And most of these softwares on the corrosion only care about the general corrosion, and for most oil and gas reservoirs applications, localized pitting it can be more important. So we have all of those corrosion types. And other factor is CFD modeling, computational fluid dynamics. And for most oil and gas problems, the type of the modeling that being required in the mathematics is kind of a simple. We don't have a lot of challenges that they have in designing missiles or aeroplanes, but the biggest challenge that we have is a geometry and how to handle a geometry. So in this software, instead of wasting like a few experts on the fluid dynamics for weeks and weeks converting solid work to something readable to ANSYS Fluent, for example, and then try to see if the convergence is happening, we just have for different type of the FCDs, we kind of create the dimensions and they just put in the dimensions for that type of FCD, and the software take care of the dimensions itself and discretize it. And also convergency is kind of a coded in the way that cause no convergency for any of these runs. And at last is the most important and frustrations of the most production engineers is to put a compilation properly in the software. And for these softwares that are available, oh man, the completion is is the biggest challenge that they got. And with this software, we create the same format the completion engineers provide Excel sheets for production engineers, and we create environments that they can just read the FCD from the library and just click on, like for example, that type of FCD, and by just putting the number of joints here to just do the mod, create their compilations ready. Now we want to see how is that Eushaw package going to help us on being user-friendly, and after understanding the solution issues. So by having user-friendly package, we only talk about a history matching part of it, which is really important because that any platform that want to be considered user-friendly have to be create the methods of automation for history matching technique. But there's other aspects of inputting also. For example, for production engineers, they always deal with pumps. And in most of these softwares, the pumps, they have to go for the converting the characters or charts in something readable for these softwares. They have to go and use other type of softwares that are kind of created for the vertical section and create the VLPs and provide it to horizontal section reservoirs. And all other techniques, they have discretized these and feed it as a sort of a tables to these softwares. But in this software, we create it as a library. So instead of going and digitizing and create the VLP for horizontal, we run the vertical section, but you can also by one click and just say the type of manufacturer and you have your model. And it's not just for ESP, we have it for PCP, progressive caddy pumps, and also ESPCP. Other important factor in all these production designs, especially once you go into the aggressive environments like thermal operations, is erosion, because we're always dealing with sands, and these sands come into our production. It also affects our history matching that I previously mentioned, but it also impact on erosion and eroding our facilities and our FCDs, our pipes. So we have to have a capability of running this inside our software. There are a few softwares dealing with erosion, but all of those are droplets. They are not handling the erosion of the sand. We also embedded this because that was requested by one of our clients, but it's really important for the operation of these flow control device. And also if you want to have a digital twin package and just diagnose in the future predictions, you have to have that capability of the erosion, but also create the inputting pretty simple, because most these engineers have no understanding of the material. So they know they have tungsten carbide or something, but they don't have a capability of converting to something meaningful for erosion models. So we create those material like a tungsten carbide, a steel, what type of a steel. We have it. And we also the type of the particle size distribution, because the sand is an input of these productions producers, and those impacting on erosion. You have to have a size distribution, but they don't have it most of the times. But we create the library that has all these PSD for different type of geology that our clients are operating the wells at. Most of the production engineers require to know what's the corrosion status is on the wells and how much of wells are corroded. The problem is most of these production engineers have very small knowledge on the corrosion, and that's not expertise. Their expertise is on the different aspects, and also their knowledge about the amount of material they have to put in these corrosion softwares, get it from the reservoir models, um, to convert it to in the format that the corrosion software is needed is also very limited. So in this software, we create a platform that that is, but as you running the reservoir simulation, you also run and model your corrosion. And most these softwares on the corrosion only care about the general corrosion. And for most oil and gas reservoirs applications, localized pitting it can be more important. So we have all of those corrosion types. And other factor is CFD modeling, computational fluid dynamics. And for most oil and gas problems, the type of the modeling that being required um, in the mathematics is kind of a simple. We don't have a lot of challenges that they have in designing missiles or aeroplanes, but the biggest challenge that we have is a geometry and how to handle a geometry. So in this software, instead of wasting like a few experts on the fluid dynamics for weeks and weeks converting solid work to something readable to ANSYS Fluent, for example, and then try to see if the convergence is happening, we just have for different type of the FCDs, we kind of create the dimensions and they just put in the dimensions for that type of FCD, and the software take care of the dimensions itself and discretize it. And also convergence is kind of a coded in the way that cause no convergence for any of these runs. And at last is the most important and frustrations of the most production engineers is to put a compilation properly in the software. And for these softwares that are available, oh man, the completion is kind of is the biggest challenge that they got. And this with this software, we create kind of the same format the completion engineers provide Excel sheets for production engineers, and we create environments that they can just read the FCD from the library and just click on, like for example, that type of FCD, and by just putting the number of joints here to just do the mod, create their compilations ready. So that we want to see what type of the packages are available in Eushaw. In Eushaw software, we combine a lot of physics, and so we are capable of modeling gas condensate reservoirs. The most problematic section of the gas condensate aggregation of states, you can use the conventional RS BO type charts. You have to have a very sophisticated PVT type models that we have it. We also capture the effects of the capillary pressure on these equation of states. All type of the models from the academic to the more practical aspects. And we also create a method that always try to use very knowledgeable and educated parameters for the parameters that users are using. Thermosolvent. This is the really problematic for a lot of reservoir engineers, production engineers to model, because in solvent applications and thermal environments, it's not just solubility and viscosity things that you have to match. You also have to be capture the density, mixture effects and the mixture density, and also the thermal properties of solvents really accurately. and you have to use some of it through the equation of states and some of it through the testing, experimental testing. So we combine all of those in one, and we also create a library that user can just use it without being really familiar with what's like, for example, what butane is really in composition or in the thermodynamic is. So you can just use butane, and for like multi-components like condensate, we also use the most representative composition for those material. We kind of eliminate geomodels because in nearby modeling, what matters is what happens around the wellbore. And as you know, it's most these companies, operators have a huge team of G&G trying to model and converting the LAS files to something meaningful for the geomodelers, and kind of a statistically populated. At the end, they have so many realizations, they have to match it, model it to get the history match. But we just use LAS files like a gamma ray, residue logs, and we use our history matching to convert those to permeability, the correlations to convert it to permeability, and other parameters that we needed to use the history match. And we also have capability of capturing exactly what happens on gas coning 1 centimeter away to like 10 meters away from the wellbores. How much is a flashing? How much is that gas flashing is mitigating the flow? And the same as I previously mentioned is a steam coning and a steam flashing and a steam breakthrough. All of these are different, but we have a thermodynamic pack module that starts with the steam flashing, and it goes to instability and coning. So now at last, I just want to emphasize our competitive advantage of the Eushaw dynamic simulator in comparison to the what's in the market currently. On the physics and the capabilities on the library, inputting, being hot paces, parallelizations, techniques and being embedded, we are more than 10 years beyond the market capabilities. And most of these capabilities not even embedded in most of these wellbore softwares. And none of them combine reservoir and wellbore in one package. So we kind of captured the gap that was between the reservoir modeling to the wellbore modeling, and also create a platform that capture a lot of other functions that the user needed, like a CFD, port network modeling, sophisticated PVT models in one package in the more user-friendly manner that user doesn't need to know a lot of those physics background. And in history matching, that our biggest advantage is, and predictability of us, is we can do in short time. We can do in few minutes, rather than like a lot of these modelings, especially once you get to the wellbore and you want to put the nonlinear completions such as FCD, it takes months and months. It's not just days, especially for thermal application, because they have a lot of convergence issues. Even if it's fixing, you can fix those. It takes very long time, more than 3-4 months to get something meaningful. And even after that, a lot of challenges they have because they're only one run. They can't. It's only few runs they have. They can't use it for history matching, and a lot of physics capture in this software is not even embedded in those. And at last, I just want to say thank you for listening to this presentation.